Okay, lesson 421, graphing transformations of rational functions. So we'll recall that rational function is a function that can be written as a fraction of polynomials. So in this lesson, we're going to rewrite rational functions in this form right here. Okay, so again, A is our stretch, compress term, our A term, and then HK is our locator point. So again, H would be right and left, transformation K would be up and down. So graphing rational functions. So without a calculator, sketch the graph of, and so we have this graph here. Okay, so think of it as a transformation. Okay, so if we think of f of x and this graph, f of x equals 1 over x. Okay, so this graph has a vertical asymptote at 0 and a horizontal asymptote at 0. And the way this graph then looks, any rational function graph is something similar to this. Okay, and so you're approaching those asymptotes, but you're not touching. So if we think about our transformation or our g of x that they give us here, we have 1 over x plus 2 plus 3. So now if we're graphing this one, we're going to move this up 3, and that's where our horizontal asymptote is. Okay, and then our vertical asymptote is at -2. Okay, because -2 is what would make the denominator 0. And then same idea, we would have this graph here, and then this graph here. Okay, again, so that's kind of what the transformation would look like. Okay, and then it says state the domain and range. So the domain, left to right, is all real numbers except x cannot be -2. The range is all real numbers except y cannot be 3. Okay, state the intercepts of the graph. So again, y-intercepts where x equals 0. So you're talking about 3 plus 1/2. So your y value would be 3.5. Right, your x-intercept is where y equals 0. So you would have to solve this, but it's not a huge importance there, right? So, where are the asymptotes? Well, again, the asymptotes are, where these domain and range can't be, right? So we got, y equals 3 and x equals -2 are our asymptotes, vertical and horizontal. In behavior, so any rational function, the in behavior, if we have a horizontal asymptote, it's going to approach that asymptote. So our in behavior is approaching 3 at both ends. So we should be able to see that there, like we're approaching 3. We're approaching 3 here. Okay? And then for this function, can you write an equation that describes the in behavior? It's that asymptote, right? It's y equals 3. That's our in behavior function. And so basically, well, I'm not going to get ahead of myself here, but we'll see that in behavior function has a lot to do with the division of the problem. Okay, so let's go on here. 51. Some rational functions can look complicated, but are simply just shifts or transformations of 1 over x. So we're going to use polynomial long division to rewrite this function. Okay, I can't get it to zoom in here. And then what do we notice? So let's take this function here and do some polynomial division. I don't know why it's not zooming in for me. Let's refresh this and see if we can't get it to zoom in for us. So while we're waiting on that, I'll go ahead and do the long division here. So x plus 2. There it is. Not how I wanted to zoom, but x plus 2 divided by 3x plus 7. So we need a 3 to go in here. So this will be 3x plus 6 Again, I changed my signs, right? You're subtracting down, but this cancels, and I'm left with 1 here. So 1 is my remainder, so it'll be plus 1 over x plus 2. So what do you notice? You should notice that this is the same as what we just graphed. So this original polynomial is the same. So where are the intercepts? Same. Where are the asymptotes? The same, right? And so what's easier for what, right? Well, it depends on what you're solving for. Okay, a lot of times the intercepts could be easier in this, in this form, in the h of k form, but your shifts could be better in this form right here. Okay, so 52. Now that we have completed polynomial division, so you can see this polynomial division without the remainder is going to be our end behavior. That's what we're approaching. So it could be horizontal. It could be an actual equation of what we're approaching. If they're, just depending on how this works out. So we have a problem here in 52 of, is there another way to do this besides long division? So let's look at this. It's kind of a neat little way to look at it. So it says rewrite 20 over 17 as a mixed number. So if we do that, sorry guys. If we rewrite 20 over 17 as a mixed number, that would be 1 3/17. That's our mixed number. Okay, so how do we do that? All right, so if you look at B, how does she do it? She takes 20 over 17. She rewrites that as 17 plus 3, and then splits this up to 17 over 17 plus 3 over 17, and then the 17 over 17 becomes 1. So it's 1 plus 3 over 17. Okay, so you can see there how she did that. So now we're going to use her same method to do 19 over 7. So this would be 7 plus 5 over 7 equals 7 over 7 plus 7 over 7 plus 5 over 7. And that's going to be 2 plus 5 over 7. Okay, so now can we do that with rationals? Well, sure, it's the same process, right? So x plus 3 over x plus 1. So again, our denominator stays the same the whole time. So this is x plus 1. Well, what do we need? We need an x plus 1, and then we'll have a plus 2 hanging out. So this will become x plus 1 over x plus 1 plus 2 over x plus 1. So then when we change this to the big 1, this will become 1 plus 2 over x plus 1. So it works the same. So whether we do long division or this, giant 1 fraction method, it's the same process, right? And so then you can see in E, they give us a little harder one here. So let's try this one. 3x plus 7 over x plus 2. So again, denominator stays the same, x plus 2. So we need to look for that. So we have x plus 2. So if you look, there's 3 x's here. So we know we're going to have 3 of these. So plus x plus 2 plus x plus 2. Well, if you look at that, 2 plus 2 plus 2 is 6. So there's an extra 1 hanging out. So what's going to happen here? You're going to have x plus 2 over x plus 2, and you're going to have that 3 times. So plus x plus 2 over x plus 2 plus x plus 2 over x plus 2 plus 1 over x plus 2. And that's going to be 3 plus 1 over x plus 2. So you can see there how that gets us, back to that same transformation look that we've been having, right? So now we consider the polynomial function, right? And it asks us to rewrite it in that form. So let's do this. So 53, we have 2x minus 5 over x plus 3. So this would be a good time, x minus 3. So this would be a good time for you to pause and you to just try this on your own. See if you can change it to this transformational form, and then graph it, state the isotopes, in behavior, all the things. Okay, so hopefully, if you tried this 2 ways, all right, so we can do long division first. So we need a 2. This will be 2x minus 6. Change the signs. Cancels. I get 1. So plus 1 over x minus 3. So that's one way to do it. If you did it the other way, this is going to be x minus 3 plus x minus 3. Now, the problem is -3 and -3 make 6. Well, I don't have 6. I have 5. So I'd actually have to add a 1 to make this work. So then this will be x minus 3 over x minus 3 plus x minus 3 over x minus 3 plus 1 over x minus 3. And then what's that going to become? 2 plus 1 over x minus 3, which you can see is the same thing we got here. Okay? So now that you have that, okay, again, if we graph this function, right, we have a horizontal asymptote at 2. That's our in behavior, y equals 2. We have a vertical at 3. And then we have our graph that would look something like this. Okay, and again, you could find the intercepts, but for the sake of time, right, this is a great idea right here. And then so 54, the last one here, says write a possible function for the graph shown. So if we look at this graph, right, where is that? So let's just say, those are 2, 4, 6. So let's say that's at 5, and then the horizontal's at 2. So if we were doing this, right, y equals okay, again, we are down 2, so that's our vertical, and then we're 1 over x plus 5, right? So again, right and left opposite the sign. So this would be a good possible, right? We could obviously have an a value that may be different, but our isotopes are the same. Cool, so this is lesson 421.